Alright guys, today we're going to be taking a look at inverse trig functions. Now this is pretty much a review from pre-calc, so all this stuff shouldn't be extremely new, but it's definitely something you don't spend a lot of time in pre-calc. So we got to make sure we cover it before we get into the derivatives and integrals of inverse trig functions. Alright, so before we actually get into doing some operations with them and doing some simplifying, we're actually going to talk about just the functions themselves. In order to make an inverse trig equation a function, we have to limit the domain and range. If you know anything about inverse functions, the domain and ranges flip-flop from the original function. So if you think of sine and cosine and tangent, any of them, they're periodic. They keep going forever and ever and ever. Well, if we were to just flip all those x's and y's, it would fail the vertical line test. Okay, so in order to actually make these functions, we have to limit the domain and range, which makes evaluating them a little bit tougher. And so that's one of the reasons why I have you guys memorize the graphs, the domain and ranges of these functions, so that when you get to a problem where you have to evaluate, you already know where it's going to be limited to, what values you have to choose from. So we're going to take a look at 5 different things for each of the 6 inverse trig functions, starting off with the 2 different names or the ways that we write them. So we're in 5-6 inverse trig functions. We're going to start off with inverse sine. Now the first way that we write it is sine with a negative first power. Now this doesn't mean 1 over sine, this means the inverse of sine, which can be a little confusing because sometimes we could write this as sine to the negative first power, but whenever we see this we assume that it's going to be inverse sine. The other way that we can write it is arc sine, ARC sine of x. Okay, that's the other way that is accepted to write inverse sine. Okay. Now, the graph for this, as I was saying, is if you were to take all the values of sine, the x's and the y's, and you flip-flop them, that will give you the points on this graph, but we have to limit it. So if we start with 0, well, 0, 0 is on sine, we can flip that, that doesn't do a whole lot. So let's think about pi over 2. Okay, pi over 2 on the x-axis would usually give us 1 for sine. Well, let's flip that. It'd be 1 and then pi over 2 on the y-axis. All right, now we're not going to keep going to the right. We're actually going to move back and think about negative 1. Well, that would come from doing negative pi over 2. So we have our points. This is going to come down like that. And there's our graph for inverse sine. Now, the domain of this is going to be negative 1 to 1. Our range is going to be negative pi over 2 to pi over 2. Yes, the brackets are important. Okay, it actually has points on those values. All right, so these are the 5 key pieces that I need you to know for inverse sine. Let's do inverse cosine. Inverse cosine, y equals cosine to that negative first power of x, and y equals arc cosine of x. Okay, those are our 2 names. Let's look at the graph. Now for this, again, we can start off with that initial point for cosine, 0, 1. Well, if we flip it, we have 1, 0. At pi over 2, cosine is 0, so at 0, we're at pi over 2. And at pi, it's negative 1, so we're going to have negative 1 pi. Goes through and does one of those deals there. And then for our domain is also negative 1 to 1, brackets. Range is going to be 0 to pi this time. And then our last one is going to be tangent for this set. So inverse tangent or arctangent. Now tangent usually has vertical asymptotes and looks like a cubic graph. Well, now we actually flip those to horizontal asymptotes, and they would be at pi over 2 and negative pi over 2. And instead of a cubic, it would look like a cube root graph. So it's going to come through 0, 0, just like that. And so for our domain for this one, it's going to be negative infinity to infinity. And our range from parenthesis negative pi over 2 to pi over 2. Now these are the three we primarily deal with in pre-calc. Okay, now in calculus though, we do get to deal with arc cosecant, arc cotangent, and arc secant. All right, so it's important that we not only know these three, but the other three. So let's go ahead and take a look at those. Now, if you miss any part of this, I do have all 6 of these written out on Canvas. You can go ahead and take a look at those and memorize that sheet. That's exactly what I want to see for the quiz you guys are going to be having tomorrow. But let's take a look at cosecant first. All right. Inverse cosecant or arc cosecant of x. All right, it's very similar to the inverse sine, except for instead of coming together, the two lines actually split apart. All right, if you take a look at your graph for sine, that'll make a little bit more sense. All right, our initial points are going to start off the same. 1 and pi over 2 is going to be up here, and negative 1 and negative pi over 2 here. And what happens is they actually turn out towards the x-axis. Okay, if you think about what cosecant looks like, it's a bunch of u's. Well, imagine splitting that and then turning them out, or turning it sideways. All right, so for our domain for this one, it's going to be negative infinity to negative 1 with a bracket, union bracket 1 to infinity, and our range is going to be a bracket negative pi over 2 to 0, parenthesis, union 0 to pi over 2 with a bracket. Okay, so there's our domain and range for that one. All right, taking a look at secant now. Inverse secant or arc secant of x. All right, very similar in the sense that it starts a lot like what we did with cosine. All right, at 1, 0, we still have a point, and at negative 1 pi, we have a point. But this time, instead of having a 0 at pi over 2, we actually have a horizontal asymptote. And the graph turns in towards that asymptote and away. And so our domain is actually the same for inverse cosecant, negative infinity to negative 1 bracket, union bracket 1 to infinity. But our range for this one is going to be from 0 to pi over 2, union pi over 2 to pi. Parentheses in the middle, brackets on the end. All right, inverse cotangent, similar to inverse tangent. Cotangent, negative 1, arc cotangent of x. With this one, instead of having horizontal asymptotes at negative pi over 2 and pi over 2, it's going to be at 0 and pi. So we draw that horizontal asymptote, and instead of going up in an increasing motion, we're actually going to be going down through pi over 2. Got a little squishy there, but again, take a look at the one I have online. The domain for this is the same, negative infinity to infinity, and our range will be from 0 to pi. So those are the other 3 inverse trig functions that we need to know, all right, to evaluate in these different problems that we deal with derivatives and integrals. Okay, so I need you to memorize, again, these 5 things for these 6 different functions, and that will be on a quiz tomorrow. Now, what do we do with it? Okay, and this is really why we learn these and memorize these. We need to evaluate these. Let me go ahead and clear this out here. Whenever we evaluate inverse trig functions, we're limited to these range values. All right, you can't just put any answer that's on the unit circle. That's really nice for regular trig, but inverse trig, because of their limited domain and range, we have to be careful what we answer with. So let's talk about evaluating some of these. Okay, when we're evaluating inverse trigs, we got to think about what is the range that values we can get out of this. So let's start off with arc sine. Arc sine of -1/2. Now, whenever I used to teach this in pre-calc, I think about this in terms of the unit circle. The range, if you remember from arc sine, is -π/2 to π/2. So if you think unit circle, that means all of your answers have to come from this hemisphere right here. All right? Here's the 0. 0 to π/2 is our normal. That's what we usually deal with our unit circle. But here, all the negative values are going to have to come from down here. So all the positive values are going to come from the top part. All the negative ones are going to come from the bottom part. We need to know where -1/2 is. Okay, so if we look here, -1/2 is going to be right here. All right, now normally that'd be 11π/6, but 11π/6 doesn't work within our range. So we have to go down, which would be -π/6. That's in our range, so our answer is -π/6. Okay, so you got to make sure that you pick a value between -π/2 and π/2. One easy way to do it is if you know that this is 11π/6, subtract 2π. If you subtract 2π, we'll put it in the right quadrant that you need. All right, let's look at another one. Inverse tangent of 1. So we need to know, where does tangent equal 1? Now this is a big one. This is one that you're going to see over and over again. And same thing, since inverse tangent has the same range as inverse sine, I would usually end up doing something like this. And I think about, okay, where on the unit circle does tangent equal 1? Well, this, like I said, is an easy one. That's going to be at π/4. Okay, and this is one of the other reasons why we learned that unit circle in the beginning of the year. You got to be quick with these. All right, let's think arc cosine of 0. Okay, arc cosine of 0. Now cosine has a different range. Arc cosine deals with just from 0 to π. And if you think between 0 and π, where is cosine equal to 0? Well, again, that one's not too bad. That's going to be at π/2. Okay, let's do one more. Okay, let me just erase some of this here. Let's do inverse tangent. So arc tangent of, let's do -√3. Again, got to work with that restricted range. So we're dealing with that right side of the unit circle, -π/2 to π/2. If it's negative, it's got to come from the bottom, okay? Because we know tangent's positive in the first quadrant. It's going to be negative down here in the fourth quadrant. So we got to think about, where is that going to be -√3? Well, again, a nice easy thing to think about here is this would be -√3 over 1, which is -√3 over 2 over 1/2. And since we know that we're dealing with sine over cosine, where is sine equal to those two values? Well, down here. Now normally that'd be 5π/3, but can't use 5π/3. We got to stay within this range. So again, go down, or you could subtract 2π from that, which gives us -π/3. So this is -π/3. All right, so there are values for evaluating these. Again, know your unit circle and know the restricted range to evaluate these. All right, so let's take a look at a little bit more challenging problems where we put two trig functions together. Doesn't make it insanely difficult, but what if we did cosine of arc sine of -√2 over 2? Well, something like this, work from the inside out. Okay? If we know what this piece is, Then we can evaluate cosine at that value. Now this is going to give us an angle measure. So let's figure out what this is here. Arc sine of negative pi over 2. Well, the negative pi over 2 comes from the pi over 4. And again, since we're dealing with just this range, we got to go down, so that's going to be negative pi over 4. So we're looking at cosine of negative pi over 4. Well, cosine of negative pi over 4, we're dealing with the fourth quadrant. Cosine is actually positive. All right, there would be our answer. Oh. It'd help if we do the right thing. So we get our negative pi over 4, and yep, we're right. Positive square root of 2 over 2. Read the wrong thing on my notes. All right, so let's take a look at one more here. All right, arctan of sine 3 pi over 2. So this, we're going the other way. The inverse is on the outside. So let's start off with sine of 3 pi over 2. Now sine of 3 pi over 2, we know from the unit circle, is negative 1. So arctan of negative 1, we actually already did this one, but we did the positive one. All right, inverse tangent, super important to know the 1 and the negative 1. Again, we're dealing with this same half circle. Negative is going to be on the bottom, so this is actually going to come from negative pi over 4. Okay, so these are just evaluating some inverse trig functions. Now, they don't always have to come from the unit circle. Okay, in fact, we don't even have to use numbers sometimes. So let's take a look at some other types of problems that we could see. All right, so given that y equals arc sine of x, find cosine of y. All right, and some of you are thinking like, what do I do here? This is crazy. I don't even know. Well, the one thing you got to understand about inverse trig function is they always equal an angle. Okay, inverse trig functions always equal an angle. So what they're telling us here by saying y equals arc sine of x, they're saying y is an angle here. Well, we can actually take this information and build a triangle based on this. So let's take that y equals arc sine of x. And let's do the inverse of each side. Well, the inverse of arc sine is sine. So if I take the sine of both sides, sine of y is actually going to equal, well, sine, arc sine cancels out, giving you just x. All right, this allows us to actually build a triangle because sine of y equals x over 1. Well, think about the ratio of sine for a second. All right, SOHCAHTOA. All right, our basic geometry and trig here. This would be opposite over hypotenuse. So we're going to build a triangle, and the angle we're going to put here is going to be y. All right, so there's our triangle y. Now opposite is going to be x, and our hypotenuse is going to be 1. We can use those two sides to actually figure out what our adjacent is going to be. Using Pythagorean theorem, all right, x squared plus, let's call it b squared equals 1 squared, b squared equals 1 minus x squared, square root both sides, our missing side, the adjacent, is going to be the square root of 1 minus x squared. So there, using our Pythagorean theorem, we're able to figure out that missing side. We'll go back to the original problem. They want to know what cosine of y is. Well, cosine is adjacent over hypotenuse. So knowing that, using our triangle, adjacent over hypotenuse, cosine of y is just square root of 1 minus x squared. And that's all we have to do for that one. Okay, so even though it looks super complicated, we're going to use this information to build a triangle, find the missing side length using our Pythagorean theorem, and then evaluate what we're looking for. Well, we can do the same thing using other expressions as well. So let's take a look at another one. All right, so instead of dealing with this, let's see what we got. All right, so now, rather than a given, let's evaluate cosine of arctangent of 2x. Okay, again, looks a little complicated. We don't have any numbers. All we have is, well, we have 2, but that's it. Here's the key. We again have to realize that inverse trig functions always equal angles. So what we're going to do is actually take this, pull it out for a second, and set it equal to an angle, and our favorite angle is theta. All right, so we're going to set that equal to theta. Just as we did before, we're going to use our inverse. Inverse of arctangent would be tangent, and tangent both sides. So if we tangent arctangent, it cancels out, giving us 2x equals tangent of theta. Well, think about what the ratio is for tangent. Okay, tangent would be opposite over adjacent, and 2x is really over 1. We can use that information to build a triangle. So let's come over here, let's build a triangle. We're going to use theta as our angle this time. Opposite's going to be 2x, adjacent is going to be 1. Well, the only thing, oh, that's not adjacent, that's hypotenuse. Okay, so adjacent is 1. Using that, we can find our hypotenuse. And our hypotenuse, again, use our Pythagorean theorem here. 2x squared plus 1 squared equals, let's call it c squared. That gives us 4x squared plus 1 equals c squared. And if we square root both sides, c is the square root of 4x squared plus 1. Well, there's our missing side. We have all of our pieces to our triangle. What are we really trying to evaluate here? I want cosine of that. Well, that's theta. So cosine of theta, right? We said that was theta. Again, cosine is adjacent over hypotenuse. Let's go to our problem here. Adjacent is 1 over hypotenuse, which we just found was square root of 4x squared plus 1. So we evaluated what this cosine of arctangent of 2x was, again, using a triangle and figuring out what just cosine of that angle is. Well, those are some different things that we did in pre-calc. Again, this is really actually nothing new. It may seem a little new because it's been a while since you've done it. All right, but it's just kind of working with those inverse trig functions. Again, the most important thing that I want you to get out of today, go through those graphs, the 2 different names and domain and ranges. You need to know those for the quiz tomorrow. All right, again, this is just practice evaluating arc trig functions. Again, this is going to show up on the test when we have it next week. So make sure you practice that. And again, some of you may need to go back and refresh on that unit circle a little bit. But all that together, we're going to set us up to start looking at derivatives and integrals the day after. Okay? Good luck.